Hello, thanks for joining me here on the BI WizKid YouTube channel. Now, I'm really excited to show you how we're going to create a star schema data model from a single flat file. How? Well, I'm going to show you exactly how to do that in a few simple steps right now. Okay, so the way this video is going to go is that I'm going to show you, I'm just going to give you a brief overview of the star schema, what it is, why it's being used, or why should we adopt it for Power BI. Essentially, Power BI, the best model that you can use for Power BI's performance and efficiency is a star schema model. Even if you've got a flat file that's got all the data in there, you know, you've got your columns, you've got your products, you've got your customers, you've got everything all in one particular file. Yes, that will work in Power BI, but you want it to be efficient, you want it to be a good experience for your users. So the best way to do that is to create that into a star schema model and then publish it to Power BI. So then Power BI has got the full benefit of using a star schema model for its analysis. So we're going to get straight into it and go straight into creating the star schema there, here. Boom.
Now I've already loaded in a simple data set. So this source is a simple CSV value here that I've loaded, and these are the columns that we have in it. So we've got line IDs, order IDs, date. We've got two dates here: ship date, a ship mode. We've got the category, subcategory, country, region, state, postcode, customer name, profit, and then some values as well. Okay, so the idea is that we're going to try and keep all the numeric values in here, and then remove all the non-numeric values into dimensions. Okay, so I guess how do you sort of go about doing that? Okay, so there's a couple of ways we can start to do that. The first thing is, let's take the customer name. Okay, so we want to create a customer dimension from the customer name. First thing we can do, we can right click on there and we can add as new query. Okay, that adds it to a new query. We can then put that into a table like that. We can then remove the duplicate, so we got a nice distinct list of our customers. Then we go to add column, and then we can add an index column from 1. Okay, I'm going to call this customer ID. Call this customer name. Okay, then I'm going to rename this to dim customer. Okay, I'm going to go back to my sales table, and then I'm going to merge a query. So I'm going to merge a query, and I'm going to say, okay, well, I've got my customer name, join that onto my customer dimension, and it should give me 9,000 odd connections, which it does. Brings in my data, my table, and then all I'm going to do is select the customer ID from there and click OK. So now that's brought through the customer ID from my dim customer table, and all these sort of, you can see there's Rosina Hoffman who's ordered a number of different times. We've now got the same number, she's got an ID there, so we can now get rid of this customer name. Okay, so then we can go through and think, right, well, okay, what else have we got in here that we can change? So we can see that we've got a category, subcategory, and we've also got a product name. So we can create a separate hierarchy for each of those, but then that's going down the route of really, you know, normalizing it to a form where we don't really want to go to, and it's not going to be efficient for reporting. So what we're going to do is create a hierarchy or a product table that has a product name, category, and subcategory as well. So the other way we can do it, so what we did last time, we right-clicked and we added a new query, and you can only do that as a single when you select a single column. Excuse me. This time we're going to right-click the actual data set, and we're going to take a copy of that. So we're going to duplicate that. We're going to go back up to this merge queries here. We don't need it, so we can delete from there onwards. So we've just got our data set. Then from here, we're going to take a category, our subcategory, and we're going to take our product name. Okay, then we're going to right click and remove all of the rows. So now again, we've only got product name, category and subcategory. From here, we're going to remove the duplicates because we only want one of each. Okay. Now here at this point, again, we're going to add an index column from 1. And that's going to go in there. I'm going to call this product ID. Move that to the beginning. Then rename this to dim product. Go back to our sales data. Now the bottom level value of that data set is the project name, so that's going to be the distinct connection that we're going to use to join onto it. So if we come back to our sales data set, merge queries, we're then going to merge on the product name, get this product name, got the same number of matches, and then we're going to expand that, and we're just going to bring through the product ID. Okay, so now because we've got the product ID, we can get rid of the product name, category, subcategory. Remove that. Okay, so now you can see that we're starting to build up all the numeric values, we're bringing in the IDs, and we're removing all the text values there as well. Product name as well. Okay. So the next main one we can see is that we've got a location dimension possibility here. Yeah. So we can do the same thing from here, and I see the bottom level is potentially going to be our postcode there. Okay. So again, we're going to right click and we're going to duplicate that. Get rid of everything from here. So we've just promoted headers, and then we're going to keep our country, region, state, postal code, and remove all the other columns. From here, again, we're going to remove our duplicates, which then gives our unique values. And then we're going to add an index column in from here. I'm going to call this location ID. I'm going to put that at the beginning. I'm going to go back to our data set, and then we're going to join this back on to our dimension using postal code. I haven't renamed the other one. I think it was that. Yep. Select columns of the same type. Okay, so let's go back here. So postal code is a text value there. We go back here, postal code is a numeric value here. So Power BI does like to change types. So I'm going to change this back to a text, because US postal codes sometimes have a leading 0, which Power BI sometimes thinks is a number. Well, is a number, but represents it as an integer rather than a text value. So keeping it as a text value keeps any sort of leading zeros that may be on there. Location, and let's try the connection again. So this time we'll merge queries again. Postal code, location, 9,000 connections, which is great. And we're going to select our location ID from there and bring that through. Okay. So we can get rid of our postal code, region, state, and country. So remove all those columns from there. Okay. So we have our order date and we've got our ship date. Now, what would be good is if we could bring in a date table. So one of the ways that I like to create a date table is to do a search on create a date table in seconds. And there's a great YouTube channel, the BI Whiz Kid, which is great. And on here, we can create a date table by simply copying this code that we've got here. Okay, so what this does is open up a function. It tells you in the video how to apply it, and it's literally is creating a date table in seconds. So you take a copy of this code. We go back to our query, and we're going to create a new blank query. We're going to go into the advanced editor, paste our stuff in there, and then that gives us a nice little interface to say, okay, well, when do you want your date to start? So we can say, okay, I want my date to start first, because I know it's 2015, I'm going to say 15, and then I want it to end on the 1st of the 1st, 2019. Okay, and then I click invoke. Now that gives me the date, the year, the quarter, the month, and then it even goes into the financial year, gives me financial information, financial month, quarters, days of month, month calendar, etc., etc. All the different aspects that you would like for a date table. It gives you there, even the ISO weeks and periods as well that you've got there you can use. Okay. So first thing I'm going to do, I'm going to change this to dim date. And then I'm going to make sure that all these values here, so the year, the quarter, the month, financial year, financial month, financial quarter, any values that are numeric, you can select them all. And if you go to transform, you can then change all those data types in one go. I'm going to change that to a whole number. Okay. So whereas if you select sort of multiple options there, you can't change the type here, but you can change the type for multiple columns if you select the option from the transform at the top there. Okay, so now we've got a connection for our date table here. At the moment we've got different formats there, so we change this to a date. I'll change this to a date, and if we really wanted to, we could connect into the date table and we could get our date integers from there as well. But I'm happy just to have that date in there. Another one we could do is ship mode. So ship mode we could add in as a new column. So again, we could right click and we can duplicate sales. Go to our data, delete until end. Okay, get our ship mode, remove other columns. We'll remove any duplicates from here, which just gives us our simple list. And then we'll add in a column that's just an index value there like that. ID. And we'll rename this to dim ship mode. Okay, go back to our data set and we will merge our queries here with the ship mode. And we'll expand this, get our ship ID, click OK, and then we can go ahead and remove our ship mode column. Now you can see that our fact table is now full of facts. So call it a fact sales. But as you can see, we've got rid of all the sort of text values, and all we're left with is our numeric values here. Yeah, we have got a order ID. Now I think the ideal would be to have an order header, order header table. So we could pull that out and put that into a separate table as well, and that would be our order header table with our order lines here. Okay, but for the time being, we're just going to leave that. I think we're happy with fact sales. We've got a dimension customers, dimension product, dimension location, ship mode, and date. Okay, so we can go through and apply this. Okay, and because we've used the same data sources, we've used it's pulling the column names across from the dimension tables to the fact tables. Hopefully, when we go into our model here on the left hand side, it's already created our star schema for us there. Yeah. And the other thing that we're going to join on here is the order date to the date, which is there. And we're also going to do the ship date to the date as well as our secondary connection for all those additional time intelligence functions that we need. So there you go. So that's from a flat file, we've now created a star schema, which now going forward is going to be a lot more efficient for Power BI when you publish it online and it's in memory and it's filtering and it's slicing and dicing from all the other different sources. Go back to this page here. So this is just a basic one, which again, I've done the same thing here. If we go and look at the model, it's the same thing that I did earlier, almost like a Blue Peter. But if we filter, we can see how instant and how quick that is as well, and how quickly that sort of moves around. You know, it really does improve the filter experience. And with this only being sort of a small data set, you really will notice the difference when you have millions and millions of rows of data. When you start filtering and you start highlighting, you will see how instantaneous it is and how much it does improve the performance of your reports. So although a flat file has all the data in there, you do need to split it out to make it more efficient for Power BI and for the user experience as well. And just here, I've created a couple of measures, doing the growth chart, which I've put in here, just showing the previous year sales as well. So looking at Q4 2017, I can see the sales that were done in that year, the profit, the sales for the previous year, and then the growth from that year as well. I can instantly sort of see that, and I can order it and see exactly which sort of categories of products sold the best and sold the most compared to the previous year as well. So we can do a lot of analysis on there and how instant that was to update all the values on there as well. Okay, so that's how we can take a simple flat file, apply a number of transformations to it. We can then split them out, remove columns, reduce the size. Our aim is to really reduce the width of the fact table. So we're removing all the different text values, we're putting them into their own individual dimension, and we've got a distinct list of that. So that's reducing that storage as well, which allows sort of Power BI to pick up that index and then go and get that data and filter it more efficiently. And you have to remember that although the file size might be slightly bigger, once Power BI pulls that model into memory, it's using that model that you've created that it pulls into memory and uses that to filter and do all your sort of analysis online. So if that model's efficient, if that model's a star schema, you will get the best experience from that.
So there you go, a star schema from a flat file. So a couple of questions that I've had. So why would you create a date table in the background and not using DAX formulas in the front of Power BI? Well, first of all, we want to reduce the burden for processing for Power BI as much as possible on the front end. So what I did was create the date table in the background, and now all the processing takes place in Power Query, and that gets refreshed periodically. However you set up your schedule refresh, when that changes, then that will run, it will get the new data, will update it, and then push it to Power BI where it's ready to use. Whereas if you create all the dates on the front end of Power BI, then every time you slice and dice, it will be running some query to calculate each of those sort of date values on the fly, which we want to sort of reduce. We want a better experience for our users on the front end. So another question that I had was, is it efficient to duplicate the table, create the connection, do the merge, connect it back up, put the index in there? The answer is yes, it is. Reason being is that we're performing those calculations and those transformations in the background of the report. So that happens once, it happens once a day, and we just set it up for it to work like that. Now, once that model that we've created that you can see in front of you is published to the Power BI service, it doesn't see any of that background stuff happening. It just sees that model that you've created there at the front end, which is a reduced data set, which has just got its IDs and its integers and its index columns connected through a star schema to its dimensions. And that's all that Power BI needs to function. So it might take some processing power, it might be slightly larger file sizes, for when you upload, but essentially the model that's in memory that's being used by the user in the Power BI service is going to be a lot quicker, is going to be a lot more efficient, and it's going to be a lot better user experience for your users. Okay, so will this affect any of the data that comes in? So let's say, the data gets updated, the data changes, we get more columns, we get more dimension values, we get more users or locations. So the way that this model was set up today, or the way we went through setting up this model today, will ensure that any new data that comes in, any new products that come in, any new customers that come in will all be updated, and the dimension tables will be updated accordingly, and all the IDs will stay the same and will match up against the fact table IDs as well. That's the way we've developed it, that's the way we've designed it. We've designed it so that going forward you will have no manual intervention required for this, unless of course you add more dimensions to your data. Okay. Now another option that we could have used is the reference option in Power Query. Now the reason I use the duplicate in terms of taking a copy, all I wanted to do essentially was take a copy of the source. Now if you noticed, in a couple of occasions, or most occasions, I took a copy of the source and then I removed all the steps that were there until just the top 2 or 3, just because I want a copy of that data set without applying any more transformations to that, so that I've just got a clean data set and I can apply, I can get the distinct list of customers, the distinct list of locations from the official source. Now with this approach you would think that all the merging and all the transformations that take place, you may find that this might take longer to do a refresh in the background. Now I don't know if you might have noticed with Power BI, when it does do its refreshes, it doesn't do it exactly on the time that you set it. So if you set it for 7 o'clock in the morning, if you check at 7 a.m. it will potentially not be running. What it does, it waits for the right opportunity and the right amount of sort of processing needs and power for it to perform that, and then it will perform it at the most efficient time for the model and for the user experience as well. And it will be done in and around that time, but you shouldn't be worried about how much processing it takes, because that takes place once a day in the background, and you don't even notice that happening. And again, we'd rather that happen in the background once a day than happen every time someone uses the Power BI report. So it's something that we sort of offset. So how many dimensions can you actually add to this star schema? Well, the answer is you can add as many as you want, really. Now you've got to think about what question you're answering here, what report is focusing on. Now you want to build a model that focuses on a certain area. So if you're focusing on sales, you want that model to just focus on the sales and the sales dimensions. You won't have hundreds and hundreds of dimensions around a sales table. You'll have up to a dozen at most, in a big organization. And if you're getting any more than that, then you need to think about, well, how can I reduce the size? How can I split the fact table to then only have a few different dimensions around it? Because again, you want to keep this model efficient, you want to keep it focused. It's going to be for a particular report. You're not going to create a model that covers every single reporting attribute you have in your whole organization. You're going to have a model that covers maybe 2 or 3 different reports, and once that's done, then you'll create a separate report or a separate model for a different set of reports. So yes, you can have as many as you want, but just make sure that it's relevant to the report that you're developing. Okay, next is, what if I already have my own unique key? What if I already have a business key in my data set? So do you still need to go through the process of creating a unique index? Okay, well the answer is yeah, you do, because a business key can still be a text value. It can still be something that could be a mixture of numeric and text value, and then Power BI will still have to scan through that text value to find that individual or that unique value. So again, creating an index for each of those as well in Power BI will create that model, it'll make that model more efficient and be able to index and scan that a lot quicker than going through your sort of business keys. So even if you do have business keys, there's no harm in creating an extra index column in there and using that for the Power BI model. So will this apply to both direct queries, and will it apply to import mode as well? So this, we've been working on an import mode, so we've imported it, we've been able to do our transformations, we've been able to create our model here. If it was a direct query, all this would be taking place on the database side or analysis services side. So you would create the similar model within analysis services and then consume that through Power BI. Okay. And that's the end of questions and the end of the video. So thanks for watching. If you have any comments, please leave them below. I will get back to you if you have any queries on any of this. Please subscribe to the channel. You'll get notifications of my forthcoming videos, and hopefully see you in that particular video. Take care.